Today we will see the material properties. Myself, Dr. Sagai Ruban, Professor and Head, Department of Civil Engineering, Rogini College of Engineering and Technology, Kanyakumari. To finalize the material for an engineering product or application, it is important to understand the mechanical property of the material. The mechanical property of the material are those which affect the mechanical strength and the ability of the material to be molded in a suitable shape. So there are some of the mechanical properties. First one is the strength, toughness, hardness, brittleness, malleability, ductility, creep and slip, resilience, fatigue. We will see one by one. First one is the strength of the material. It is a property of a material which opposes the deformation or breakdown of the material in presence of the external force or load. Material which we finalize for our engineering product must have the suitable mechanical strength to be capable to work under different mechanical forces or load. Second one is the toughness of the material. It is the ability of the material to absorb the energy and get plastically deformed without fracturing. Actually, it is in joule per meter cube. It is determined by the amount of energy per volume. The value of toughness of the material can be determined by the characteristic of the material. That is the stress strain characteristic of the material. Next one is the hardness of the material. It is the ability of the material to resist to permanent shape change due to the external stresses. There are various measures of hardness. First one is a scratch hardness. Second one is a indentation hardness. Third one is a rebound hardness. Next one is a brittleness of the material. So it is a ability of the material indicates how easily it get fractured when it is subjected to a external force or load. When a brittle material is subjected to a stress, it absorbs very less energy and get fractured without significant strain. The brittleness is converts to a ductility of the material. The material actually the temperature dependent. The brittleness of the material actually the temperature dependent. Some metals which are ductile at a normal temperature become brittle at a lower temperature. Next one is a malleability. It is a property of the solid material which indicates that how easily a material get deformed under the compressive stresses. The malleability is often categorized by the ability of the material to be formed in the form of thin sheet by hammering or rolling. Normally, the malleability of the material is a temperature dependent. That is, when the temperature increases, the malleability of the material also increases. Next one is the ductility property of the material. So the ductility is a property of the solid material which indicate that how easily a material get deformed under the tensile stresses. The ductility is often categorized by the ability of the material to get stretched into a wire by a pulling or drawing. This mechanical property is also an aspect of plasticity of the material and it is a temperature dependent. So with the increasing temperature, the ductility of the material increases. Next property is creep and slip. Creep is a property of the material which indicate the tendency of the material to move slowly and deform permanently under the influence of the mechanical stresses. It results due to the long time exposure to the large external mechanical stress within the limit of yielding. Next one is a resilience. It is the ability of the material to absorb the energy when it is deformed elastically by applying stresses and release the energy when stresses is removed. Next one is a fatigue of the material. Fatigue is the material cast repeated applying loads. That is, if you are applying load repeatedly, that material get fatigue. So it is a progressive and localized structural damage that occur when a material is subjected to cyclic loading. Normally, the fatigue failure occurs when material is subjected to the repeated loading. Actually, that stress will fail at a stress much lower than the tensile strength. The fatigue failure will occur without any plastic deformation. Thank you so much.